All right, section 2-5, reasoning in algebra and geometry. All right, so first we're going to circle each equation. So basically an equation is an expression, it's something that sets two expressions equal to one another. So the equation is this one. Plus the hint is there's an equation sign there. Okay, so write an equation to represent each problem. Sarah has 5 more than twice the number of apples that Greg has. If Sarah has 21 apples, how many apples does Greg have? All right, so Sarah has 5 more than twice the number of apples that Greg has. So notice how this is being compared to Greg. We're going to call Greg's apples X's. Okay, Sarah has 5 more than twice the number. 2x plus 5. 5 more than twice x. Okay, if we know Sarah has 21, then we can solve for x. Let's try this again. Your brother does 1 less than twice the number of chores than you do. So let's call this x. If he does 7 chores, how many chores do you do? So your brother does 1 less than twice the number of chores. Twice the number of chores you do, 1 less is 7. So here is your equation. So to justify, which comes from some related words, justice, justification, justifiable, justly. The definition, to justify a step in a solution means to provide a mathematical reason why the step is correct. When you justify an action, you explain why it is reasonable. So draw a line from each equation in column A to a property we would use to justify it in column B. So what does 3 plus 7 equals 7 plus 3? Well, this property is the commutative property of addition. 12 times 4 is the same as 4 times 12. That is the commutative property of multiplication. 2 times 5 times x is the same as 2 times 5 times x. Notice the only thing that's different is the way we grouped them or associated them. This would be the associative property of multiplication. 1 plus 9 plus 53 equals 1 plus 9 plus 53 is the same, so associative property of addition. All right, so we're going to complete this graphic organizer. So this is a whole bunch of properties here, okay? So let's start at the top and work our way around. So if A equals B, then B can replace A in any equation. This is substitution. If A equals B, then A times C is the same as B times C, okay? If A equals B and C does not equal 0, then A divided by C is equal to B divided by C. Transitive property. If A equals B and B equals C, then A equals C. Symmetric property. If A equals B, then B equals A. Reflexive property. If A equals A. The addition property. If A equals B, then A equals C equals B plus C. And then subtraction. If A equals B, then A minus C equals B minus C. And those are all of the properties of equality that we need to know. So the substitution property of equality, multiplication property of equality, division property of equality. So all of these are the properties of equality. An additional property is something called the distributive property, where we can distribute over a sum or a difference. So for example, 5 times 24 is the same as 5 times 20 plus 4. So I would distribute the 5 to each number. So that's 5 times 20 plus 5 times 4. And that's how I get 100 plus 20, which equals 120. It's the same thing. We can write 17 times 3, the same as 20 minus 3 times 3. And I could distribute the 3 now. So 20 times 3 minus 3 times 3. And that's how we get 60 minus 9, which is equal to 51. Okay, so let's justify steps when solving an equation. So what is the value of x? We know that AB bisects our angle RAD, so it cuts it in half, 2 equal segments. So what does that tell us? Well, it tells us these 2 angles are congruent. Okay, so next thing, if we know it's congruent, or the bisects, then we know this angle is congruent. RAB is congruent to NAB. Definition of angle bisector. Okay, well, If angles are congruent, then their measures must be equal. All right, so we know measure of angle RAB is equal to x, and the measure of angle NAB must be equal to 2x minus 75 from the picture. Okay, what we're going to do is subtract x from both sides, and we get x minus 75. We're going to add 75 to both sides, and we get x equals 75. And that is how a nice proof is written. So, put all of these together, we have our reflexive properties, our symmetric properties for segments and angles, and our transitive properties for angles and segments. So very similar to how numbers work in our algebraic sense. So let's complete each statement. If I know that angle P is congruent to angle R, and angle R is congruent to angle A, then I know angle P must be congruent to angle A. Okay. If angle X is congruent to angle N, and angle N is congruent to angle Y, and angle X has to be congruent to angle Y. If angle L is congruent to angle T, and angle T is congruent to angle Q, then angle L is congruent to angle Q. So how do we write a two-column proof? Well, a two-column proof is simply writing each step from given information to what we want to prove, okay? And then for each time we write something, we have to provide a reason for why we can write it. So this is where we get the two-column proof from. And a lot of times we write it like in a table format, and that's where we get the two columns from, so statements and reasons. All right, so we start off usually with our given information. So it's given to us that AB is congruent to CD. All right. Now, congruent segments mean they have the equal measures. So congruent segments have equal measure. All right, well, BC is congruent to itself. This is called the reflexive property. All right. AB, so I look here, and I'm going to add BC to both sides. So I'm adding BC to both sides. This is called the addition property. Okay. Well, what is AB plus BC? AB plus BC equals AC. BC plus CD is equal to BD. That is called the segment addition postulate. And then finally, if we have congruent measures, it means we have congruent segments, or equal measures mean congruent segments. So this is called definition of congruence. And there is a full two-column proof. Okay, so let's see if we understood what we're talking about. So fill in the reasons for this algebraic proof. So the very first step to the proof is what we're given. Okay, so the first thing I wanted to do here in this statement is to subtract 1 from both sides. So the number 1 was subtracted from each side of this equation. The reason I can do that is the subtraction property of equality. Next, I wanted to divide both sides by 5, and that is the division property of equality. All right, so right in the steps that we have, our first step was given, our second step was subtraction, and then our third step was division. And that is the end of that section.